Dear students, in this video, let us revise the experiment of resonance in LCR series circuit. Aim of the experiment is to set up LCR series circuit and to determine the resonant frequency, bandwidth and quality factor for the given different values of resistances. This is the circuit diagram used for the connection. It consists of AFO, resistance box, inductance box, capacitance box, a key and the milliammeter. Before going for the circuit connections, it is essential for us to set up the input voltage. So, to set up input voltage, connect the terminals of AFO to voltmeter kept in AC mode. Adjust the value of frequency to 1 kHz in AFO. Set the voltage to 2 volts using fine level knob in AFO. Now, the input voltage is set. Disconnect the connections between voltmeter and AFO and connect the circuit as shown in the figure. Set the values of R to 50 ohm, L to 3.5 millihenry and C to 0.22 microfarad. After keeping the values of R, L and C, now the circuit is ready for recording the observations. Note down the values of current for different values of frequency ranging from 1 kHz to 10 kHz with an interval of 1 kHz. Similarly, record the values of current for R is equals to 100 ohm and R is equals to 150 ohm respectively. Now plot the graph of current versus frequency. You will get a graph as shown. This is the point for which the value of current is maximum for all values of resistances. Draw a perpendicular line to the x-axis from this point. The point where this perpendicular line touches the x-axis gives the value of resonant frequency. From the graph, it is also clear that this is the point for which the current is maximum for 50 ohm resistance. So now this value is taken as I0 and the value of I0 in this case is 11.6 milliamperes. When now you multiply this value of I0 with 0.707, you get the value around 8.2 milliamperes. So now draw a parallel line from this point so that this line touches both the edges of the graph. So this is a point where this line is touching the left hand side of the graph. So draw a perpendicular line to the x-axis and you get a point known as F1 which represents the lower cutoff frequency. Similarly, from the point where the line is touching this point onto the right hand side of the graph, when you draw a perpendicular line, you are going to get one more value of frequency called F2 which is also known as upper cutoff frequency. So students, from this graph we obtain three values. One is F0 which is representing the resonant frequency, F1 which is representing the lower cutoff frequency, F2 which is representing the upper cutoff frequency. By using the values of F0, F1 and F2, we can calculate the values of quality factor, bandwidth, QL and QC. Students, just make a note that here if you guys are using the values of R as 100 ohms, then the values of F1, F0 and F2 must be taken with respect to the 100 ohm curve. So this is how we are going to calculate the things. I hope this video is helpful for you all in revising the experiment. Maintain social distance, stay home, stay safe.